Hello everyone, welcome to rkphysicsshiksha. I am RK sir and I will be your guide on this journey of learning physics in a simple and easy way. In this video, we are going to learn a chapter which is motion in a straight line. Motion actually is all around us. For example, a car moving on a highway, a ball rolling on the ground, or even a person walking into a school. How to describe this motion more significantly is what is very important. Suppose, for example, if your friend says, I ran fast today, that doesn't tell us much about the motion. But if they say, I ran 100 meters in 12 seconds in a straight track, now we exactly can calculate how far they ran or how fast they ran, and all these things which are to be calculated about the motion is what we are going to learn in this chapter. So in this chapter, we will study the simplest type of motion, which is a straight line motion, or we can also call it as rectilinear motion. Rectilinear motion, or motion in a straight line, or one-dimensional motion we can call it as. So we will learn the basic concepts like distance, displacement, speed, velocity, and acceleration. And we'll use graphs and equations to describe motion precisely. So this chapter is actually the foundation of mechanics. Once if you master this, you can easily understand motion in 2 and 3 dimensions, and for example circular motion and even in projectile motions. So getting into the chapter first, let us know what is rest and what is motion. Before going deeper into the concepts, let us first understand what we mean by rest and what we mean by motion. So rest and motion. What do you mean by rest and what do you mean by motion? Rest. What do you mean by rest? A body or an object, for example, an object, if you consider, is said to be at rest, is said to be at rest if its position does not change with respect to its surroundings. For example, a book that is lying on the table is at rest with respect to the table. And similarly, what do you mean by motion of an object? What do you define motion as? So the same thing, an object is in motion if its position changes with respect to the surroundings. An object is said to be in motion if its position changes with respect to its surroundings. And for this, we can take an example, the same book, whichever is there lying on the table, is in motion with respect to the sun, because the earth itself is moving. So we can say that the book on the table in relative to the sun is actually in motion. So I am telling you, like, it was initially at rest with respect to the table, but you are considering if it is with respect to the sun, it is in motion. So by this, what we say is rest and motion are relative terms. So rest and, you can say that like rest and motion are not absolute. Rest and motion are not absolute, but they're relative. They're relative concepts, meaning relative terms, not absolute. They are relative. They are relative. For example, I'll give another example in related to this. For example, assume there is a car going, or there is this path on which there is a car, that is, or a truck in that case, a truck moving in this direction. A truck moving in a one dimension, or a bus moving in one dimension. Now, for example, if there is a person sitting in the bus or standing in the bus, there are two people standing in the bus, one here, one here. With respect to each other, they are at rest. With respect to each other, both of them are at rest. But the same two persons are not at rest with the person who is standing on the road. With respect to the person who is standing on the road, both these persons who are there in the bus are in motion. So this means whether something at rest or in motion depends on the chosen reference frame. With respect to person number 1, person 2 is at rest. But with respect to person 3, both 1 and 2 are in motion. So we define rest and motion are relative concepts. Please remember this very clearly. It's very, very important also. Rest and motion are not any absolute terms. They actually depend on the reference point or the chosen reference point. And now, as we know what rest and motion are, once the object is in motion, we need a way to measure how far it has moved. So now we'll get into the concept of distance and displacement. I will get into the concept of distance and displacement, where we are going to measure how far a particle has moved. So coming to that, first we'll discuss about distance. We'll discuss distance first. How do you define distance? What is distance? It's the total path length covered by an object. It is the total path length covered by an object. By an object. It is the total path length covered by an object. It only tells us how much ground was not covered. How much ground was not covered. My mistake. It only tells us how much ground was covered and not in which direction. If it doesn't, or we don't discuss anything about its direction, but it is just the ground that was covered. For example, I walk 10 meter, it doesn't matter what path which direction I take, but my path length is what I take as the distance. And this distance is a scalar quantity. It's a scalar quantity. Distance is a scalar quantity. Is SI unit. SI unit is meter. And dimensional formula or dimensions will be M0, L1 and T0. These are the dimensions. That is a scalar quantity. Now talking about displacement. Talking about displacement. Here, this is the shortest distance from the initial position to the final position, or even specifically, it is the shortest straight line distance. It is the shortest straight line distance from the initial position to the final position. Along with direction. So it's a vector quantity. Displacement is a vector quantity. And its SI unit and dimensions are the same as that of SI unit is beta. Dimensions also the same as that of distance, which is m0 L1 t raise 0. This is the displacement. Now let us just go a little more deeper with an example or graphic or diagrammatic representation here. For example, let me take a particle starting from A and it will travel a distance randomly, taking a random path like this. Okay. Or let me just be very much clear, like a random path like this, and lands up at the point A. And now this length through which it has traveled, that is this portion, this we call it as the distance. This is the distance, that is the actual path length of the particle. Now what is displacement here? The shortest distance between the 2 points, that is the initial and the final points, the shortest distance. This here, or I'll just take another color better. So this point from initial to the final point will actually be taken as the displacement. This is displacement. So now if you look at this diagram also, we can clearly say that the magnitude of displacement, very important, magnitude of displacement is always less than or equal to distance. Because the shortest possible path that is between any 2 points, that is initial and final points, will always be a straight line. So you cannot have any path less than this straight line. So magnitude of the displacement will always be less than or equal to distance. In what case will it be equal to distance? The magnitude of displacement, that is the magnitude of displacement, will be equal to distance in a straight line motion. We clearly can say that the magnitude of the displacement and the distance are same. And now coming to few examples, if we are going to discuss few examples. For example, let us take a case like this, where I'll just take a question here. Let me consider a person, or oh sorry, I forgot one more point here, very importantly. I'm really sorry about it. Right, displacement can be 0, negative, or it can also be positive. But if you consider distance, always positive. Distance is always positive. So I can give you a few examples on this also. Let us discuss few examples in related to this last point that I gave you as numericals as well, like sort of numericals. For example, example 1, let me consider. Take example 1. So in this example, a body travels east, or a body let me just write the data instead of writing the whole question. So a body travels 4 meters east and turn and takes towards north a 3-meter distance. That means if a particle is moving like this, a particle is moving 4 meter east and it moves 3 meter north. Okay, let me just take a scale also. North, south, east, west. Correct? Yes. Right. Now, this is moving 4 meters east and 3 meters north. Now the question is, in this case, what is the distance traveled and what is the displacement of the particle? What is the distance and what is the displacement? You are supposed to calculate it. Coming to the distance, you have to calculate the distance. Distance is equal to the actual path length, which is 4 meter plus 3 meter. That gives me 7 meters. And what about the displacement? Displacement is the shortest distance between the 2 points. So this will be the displacement. A straight line between the points. This is the initial point. This is the final point. So this will become the displacement, which is the hypotenuse here. So in that case, displacement is equal to how much? Displacement is equal to root of 3 square and 4 square. 3 square plus the 4 square. So it will be 16 plus 9. And that gives me root of 25, which is equal to 5 meters. So the displacement is 5 meters and the distance traveled is 7 meters. And coming to another example. For example, let me consider another example here where the displacement taken to be, let's take an example where we can have displacement to be 0. So assume that you're throwing an object from the ground. And it goes up to a certain height h. It travels to a certain height h. And it comes back again. It goes up and it comes back again along the same path. Now, if you look at this case situation, the initial and the final positions of the particle are the same. So that means they are going to ask you what is the distance in this case. The distance in this case is going up, it is traveling h distance, and coming down, it is traveling h distance. That means the total distance traveled will be h plus h, which will be 2h. And coming to displacement, the initial and final positions are the same. So displacement will be 0. This is one more example. Now let us take one more example in related to this, example 3. For example, I take a semicircular path. A semicircular path for a particle, a semicircular path of radius r. So a particle starts here and it will come back. It will take a path as you see here in the diagram. It is not coming out a proper semicircle. Right. Sort of a semicircular path. Or else I better take the circle and cut it. That gives it a better presentation. Right. So particle have a semicircular path starting here and ending up this. This is the initial position. This is the final position. Now this semicircular path has a radius of r. The radius is r. This is r and this is r. Now in this case, what is the displacement and what is the distance? So in this case, the distance traveled by the particle distance will be equal to, it will be the length of the this path here, this path, this portion, this length. There will be circumference of the circle is pi r. So here it is half of the semi circumference. So it will be, my mistake. Circumference of the circle is 2 pi r, and here it is half of it. So it will be pi into r. This is the distance traveled. What about the displacement? Displacement in this case is actually equal to 2 times r, because it is the distance between, or it is the path that is the shortest distance between A and B. This is one more example. If you take a full circle, a complete one revolution if you consider, and if you are supposed to calculate the distance and displacement in that case, distance will be 2 pi r, but what about the displacement? Displacement will become 0, because the initial and the final positions of the particle will be the same. The initial and the final positions will be same. And one more very important note point, if you remember here, I'll just note here. If you take the ratio of the magnitude of displacement and distance, remember, displacement, magnitude of displacement by distance is always less than or equal to 1. It will always be less than or equal to 1, or you can also say it, distance by displacement ratio is actually greater than or equal to 1. This is, I should have given it a little earlier, but yeah, now also it's fine. Right. Next, there is one more example where we can calculate. For example, I'll just give this question, the last example. So in this example, there is a circular wheel of radius r. We consider a circular wheel of radius r, a circular wheel of radius r that is moving on a track in a straight line. So this, it has having a radius of r, and now the wheel actually travels half of the distance. Okay, let me just complete the diagram. Now it is traveling on a track. As you see here in the diagram, this wheel is traveling on a track. Now this wheel, this is a one point, this is point P, this is the wheel. What happened here is it actually completes half a revolution. Means it completes half of the revolution. Means this point here will actually come up to this point here. Meaning if it moves along this horizontal path, this point goes up and this point comes down. So that means it will travel a particular position here. Now what they are going to ask you here is, what is the distance and what is the displacement? If you look at this diagram, now this point P goes up for a half circle and it will travel only, okay, let me consider this. This is P1 and P2. P1 goes here, P2 comes back here. So now what they are going to ask you here is, what is the distance and what is the displacement? So for that, so this here will become the displacement, and this portion, this straight line that is there connecting P1 and P1 there. So this here will become the displacement, and the displacement and distance. Yeah, this here will become the displacement, and this portion here will be the distance, which is obviously AB, P1, P2. This portion obviously will be how much? Half of the semicircle, that is pi into r. Now, as I told you, its radius is r, so this whole thing here will become 2r. So now they're asking you, what is this displacement? This displacement you can consider P1. P1 is the displacement. This portion here is the displacement. So for that displacement, which is P1, P1, I can just use the hypotenuse, the Pythagoras rule, which is hypotenuse square is equal to adjacent square, root of adjacent square plus opposite square. That will give me P1 will be equal to root of pi square r square plus 4r square. Now that gives me root of pi square plus 4 into r square, which is equal to r times of root of pi square plus 4. This is the displacement. And if you are going to calculate the distance, 1 minute. If you are supposed to calculate ratio, also you can do that. And distance here is, I'll just write it here. Distance will be half revolution, and it definitely will be pi r. So now if they ask you to calculate the ratio, you can calculate the ratio. So if you were supposed to calculate the ratio of distance and displacement, distance by displacement will be equal to pi r divided by r into root of pi square plus 4. So from which I get r gets cancelled, and I'll get pi divided by root of pi square plus 4 as the answer. Hope you understood. And so to summarize what we discussed rest and motion are relative concepts, and distance measures the total path length, while displacement measures the shortest path with direction. And both these concepts of displacement and distance we have discussed in relative to using some numericals. We elaborated them as well. In the upcoming lessons or upcoming videos, we will build on this and explore speed, velocity, acceleration, and the equations of motion. Thank you for watching, and bye.